Hello YouTube viewers, Namaskar. In this particular video, I'll be talking about frequency distribution. You know what is frequency and what is how its distribution. So we'll be discussing the fundamental and the basic concepts of the frequency distribution, that is the technique that is used in the statistics for classification or grouping of the data. And this frequency distribution is a very important phenomena and concept that we must understand if you need to know what is and how to apply the statistics in your chosen discipline. Now we'll start with the definition. You know what the frequency? Frequency means the fact or state of being frequent or happening often, occurring again and again. That is the frequent. Means something occurring again and again, that is known as the frequency. Then the process of classifying raw data into categories. That is, raw data means the original data which you have collected. From that data, that has to be the frequency distribution comes under the data profiling. If we are a researcher and collecting some data, that data has to be first classified into categories, and for that classification the frequency distribution is one of the techniques, because the data which has been classified or grouped acts as a raw material for the further higher statistical techniques. So that is the definition. One more I'll let you know. The frequency distributions are visual displays that organize and present frequency counts so that the information can be interpreted more easily. This means the raw data that has been classified and grouped using the frequency distribution technique, that data can be easily understood. That data is presented in the visual form so that just at one glance it can be understood what data wants to say. So it's a very important and one of the basic concepts of statistical techniques. Now let us take an example. In that example, we'll be taking ungrouped data. This is a table in front of you, table 1.1, and I'll say here that this is purely hypothetical data. Suppose we collected this data on some independent, some variable, some dependent or independent variable, psychological variable. See, this is you call as a marks of students out of 60. Total, you take it as 60 marks. There was a test given to the students and they scored 60 out of 60 these marks. So this is ungrouped data. You just collect the data and tabulated it. That's enough. This data is further classified and grouped using the frequency distribution. Now, that was an example of the hypothetical data. Let us first introduce you something more about the frequency distribution. The collected data are to be organized in systematic order by classification and categorization, which I told you. This is required because a disorganized data set hardly conveys any meaningful information. The data set which you've seen in the previous table, that doesn't conveys any meaning. You have to be a little bit more observant so to pick out what the data wants to say. But to prevent that or to give some meaning to data, the data has to be classified and organized into some categories. And out of that categories, one of them is the frequency distribution. So to extract the exact information from data set is to be organized and classified by grouping it into various categories known as the frequency distribution. The frequency distribution must adhere to the following steps. There are some steps that are mandatory for the researcher or experimenter or the student to adhere to while categorizing or grouping the data using the frequency distribution technique. So what are they? The first step is determine the range of the data set. You know what is the range? Range means the difference between the highest, the score and the lowest score. That is the range. So first step is we have to calculate the range of the data set. Then comes the decide upon the class intervals. Means you have to make the class intervals and that intervals has to be decided upon depending upon the range and the you know what are the class intervals? These are the groupings, so that the data can be, that frequencies can be allotted to the specific or particular class intervals, so that the data has to be grouped or classified into, in the second step, into class intervals. Then comes the tally the scores. We have to make the tallies as far as the when we are calculating the how much cases fall in a particular class interval. That number of scores has to be represented or entered in just in front of the particular that specific class interval, and that is known as tallying the score. And finally, transform the tally into frequencies. So these are the four basic and fundamental steps that are to be adhered to while we are grouping the data into frequency distribution. So earlier was the first table 1.1 was the raw data, and that was ungrouped data. The same table, for your convenience, I have picked up here. This is on the same table. This is a row score and this is ungrouped data. Now this ungrouped data is converted into frequency distribution like this. So I'll explaining you each concept in little bit detail, and if you have any problem, you want to know anything, just you can write in my comment box, and you can directly email to me. My email, you know, vermasujit@yahoo.com. So these are the frequency distribution table. So this data is ungrouped data, and this one is known as the group data, because that scores are grouped into certain frequencies. These are the class intervals, this is the tally, and this is the frequencies. So you know this one. Do not worry. I'll explain each particular concept in little bit detail. What are that? First one, determine the range of the data set. You know, range means the difference between highest and lowest score of a data set that I explained earlier. In our example, the range is 56 minus 14. So you want to see, let me show you, I will go to the previous slide and will explain you. See, this is the highest data set, highest score, and this is the lowest score. So difference between the highest and the lowest score is known as the range. That is 42. The second step is the decide upon the class intervals. That is the size of groupings. You know what is a class interval? That I show in the previous slide, which I shown you, the second table, that the data is in the grouped state. The first column itself contains the class intervals. The mutually exclusive categories designed to accommodate complete data set. Do not worry, I'll explain you once again. I'll show you the same table. So this is your frequency distribution. These are the class intervals, because these class intervals contains the number of frequencies or the tallies. Okay, so this is the second step as far as the frequency distribution is concerned, that is the deciding upon the size of the class interval. Now we'll be discussing how to decide upon the class intervals. We discussed these are the mutual categories. Now let us discuss some customs or traditional procedures or methods followed by various researchers to decide upon the size of the class intervals. As suggested by the Guilford and Fruchter in 1978, the size of class intervals are usually decided on the basis of following two customs. Remember, these are not scientific steps. These are merely customs or the traditions generally all researchers or scientists follow. Again, I am telling, these are not the standard steps or the algorithm, purely two customs. So the first custom is the intervals should not be fewer than 10 and not more than 20 or sometime 15. That is, as per your data, your class interval must be minimum 10 and maximum they should not cross 20, or sometimes they should not go for 15. If data is large, you can increase the class interval size. If data is smaller, then the class interval size can be decreased. So this is the custom, and we generally follow this custom, but this is not a fixed rule. Then the second one is the interval size of 2, 3, 5, 10 and 20 are mostly preferred. Means if data is the quantity of the scores are lesser, then the class intervals can be 2, 3, 5. If it is larger, then it's 10, 20. So this is the usually or mostly preferred class interval sizes. Okay. In our example, the range is 42. You know, the class interval of 3 will be good choice. Why? Because if we divide the range 42 by proposed class interval, that is 3, we get 14 intervals, which is within the ambit of 2 customs. So how to decide upon the class interval? This is a very important point. The students face this problem and they ask, okay, how to decide upon the size of the class interval? It's a purely trial and error method. You just calculate the range, and you know that usual preferred size of class interval is 2, 3, 5, 10 and 20. So out of that, divide your range with the one of the classes size of the class intervals. The answer must be between 10 to 15 or 10 to 20. If that is okay, then that class interval size will be better and appropriate for your grouping of your data. So that was the 2 customs I discussed as far as the deciding the size of the class interval is concerned. Then comes we'll discuss something important terms that are related to class intervals. What are that is, because in long term, they are the basic points and basic concepts. We must know that. So few terms that we are going to use frequently when we are using the statistics in our research. So these terms must be clear in your mind. The first one is the score limits of intervals. So this term we will be using frequently. The lowest and the highest scores of each interval are called the score limits. The name itself is self-explanatory. Limits of the scores, the lowest limit and the highest limit of the class interval are the score limits. In our example, table 1.2, score limit of first interval are 14, that is the lowest one, and the 17, that is the highest one. So this particular terms you must remember this. Then comes what are the exact limits of class intervals. So this is the most common point where students get confused. They ask what is the exact limits and why we calculate this exact lower limit or higher limit of a class interval. Dear friends, the exact lowest and the highest scores of an interval that encompasses the class interval, they are known as the exact limits of the intervals. That is exact lower limit, exact highest limit. For example, the exact limits of the first interval are 14.5 to 17.5. The adjacent figure, which I have just taken from the Guilford and Fruchter book that is published in 1978, this beautifully explains why we need to have exact limits of a class intervals. See, in our example here, you can see here, if your class interval is 9.5 to 14.5, in that case, the score which is having a value of 9.6, that will come under this class interval. Whereas, if the score has a value of 9.4, that will not be contained or encompassed in the particular this class interval. Similar is the case here. If your class interval is 42 to 44, in that case the exact lower limits will be 41.5 and 44.5. Because if the score, the value of the score is for more than 41.5, in that case that score will fall within the ambit of this class interval. And similarly the case with the 4 example, beautiful example and visual images given by the Guilford and Fruchter. So you can understand and you must know why we calculate the exact limits, because to encompasses the total data within that class interval. So that is the reasoning behind the calculating the exact limits of class interval. So next we'll be calculating midpoints of an interval. This is also a very important point. What are the midpoints of the class interval? The scores grouped within a given interval in a frequency distribution are considered to be spread evenly within that interval. So this is a very technical sentence. I'll explain you. Suppose there is a class interval, and in front of that class interval there is a frequency given 5. Okay, and the size of class interval is 3. In that 3 points, the 5 frequencies are supposed to be, they are considered by the researchers are evenly distributed. Getting my point? So if you want to know how much space one frequency clears or have in that particular size of the class interval, then what you have to do is you have to divide 3 by 5. Getting my point? So each frequency of that particular class interval having the size of 3 and the frequency is 5, in that case each frequency have a space of 0.6. So that is the reasoning why we used to have decide the midpoints of an interval. That is, the scores grouped within a given interval in a frequency distribution are considered to be spread evenly within that interval. To represent all scores in the single value, the midpoint of interval is calculated. So you know all values are evenly distributed within the size of the class interval. So which value or which score, the single score that represents the total frequency or total the class interval? Certainly, my dear friends, that is the midpoint. Okay, so midpoint of interval is always equal to exact lower limit of the interval plus then exact upper limit minus exact lower limit divided by the 2. In our case, for example, the midpoint of interval 26, 29 is, so the exact lower limit will be 26.5, exact higher limit will be 29.5. So 29.5 minus 26.5 divided by 2 and adding 26.5, that is 26.5 plus 3 by 2, that is 26.5 plus 1.5 is equal to 28. My dear friend, this is the exact or the midpoint of the class interval. Then comes the next point is the tallying the scores. This is very important. The listing of scores or observations within the class intervals. The scores are represented by tally marks as shown in table 1.2. As I showed you in the table 1.2, how the tally marks are represented. This means the listing of scores or the observations within the particular class intervals with the marks, that is known as the tally the scores. Then the next and the fourth important point we'll be discussing the transforming the tally into frequencies. So the tally marks or symbols are converted into numbers which are called the frequencies, as you seen in our table 1.2. Then suppose there are 4 straight bars, that means these are the tally, and then in the frequencies you have to make it as you have to write as a 4. But if there are the 4 and there is a cross mark, these 4 are crossed, that is from one top corner to the bottommost corner, that means that is a group of 5. Getting my point? 1 bar, 1 vertical line is 1, 2 vertical lines are 2, 3, 3, 4, 4. Then there comes the 5th one. As far as the 5th one is concerned, in that case, this is the 4 tally marks. Then 5th one will be like that, this way. This means this is a group of 5 scores. So in front of that you will write 5. If this is a 5, then there is a 1 more extra, then it will be 6, 7, 8, 9. As far as the 10 is concerned, so you will have a group of 5 tally marks, group of tally marks. So that in case the frequencies will be 10. So this way will transform our tally into frequencies. The sum of frequencies represented by, there is a one special sign. This is a capital Greek letter, and it is called as the sigma, and this indicates or this stands for sum of summation. This will be read as the summation f, means summation of sum of total all frequencies. This means the total of frequencies. You must know this point, you must know this symbol. This symbol represents the sum of or total. So these are the 4 points, 4 steps we follow in the construction or frequency distribution, transforming these scores into frequencies. Dear friends, we have discussed meaning the frequencies, definition of frequency distribution, then the steps are the 4 steps that are involved in the frequency distribution. Along with that, we discuss the sub parts of frequency distribution, that is class interval, how to decide upon the size of class interval, and what are the customs followed to the how much class intervals we should have. So these are all my references. You must refer these books. Guilford and Garrett books are very, very important for you for learning the basic statistics. So this is all about today's topic, that is frequency distribution. In the next video, I'll be talking about the graphical representation of data. By the time, if you like this video, share with your friends. But if you dislike it, or if you have some queries, just write to me either in my comment box, or you can directly mail to me vermasudit@yahoo.com. My dear friends, thank you very much for showing your patience and watching this video. Meet you soon with the next video, that is graphical presentation of data.